Bottom. It's not about my arse or yours. When it comes to your drill bits and your drills, don't get throwing them out. Stay tuned, watch this video and we'll show you the reason why. Flat bottom, what's it all about? Take a look at this drawing and imagine these are two pieces of steel. When you drill to any depth, it leaves that telltale triangular shape cut. If you've got something, say you're working to a drawing and they want you to make something with a cap screw that sits inside the job and have a flat bottom so it sits nice and securely, say this is the top piece to something that the whole thing screws down on top of something. They just want things flush on the top. They want the screw to sit inside the metal and not on top of the piece or sticking out as we usually see, to sit flush just like that. You can see there he's sitting at the top, but in the top piece we've still got that triangular piece underneath. That won't hold it as securely as we'd like, so we would like to have a flat bottom for that head on that cap screw to rest. As you can take a look at the cap screw, you can see how it's flat at the bottom, even though it is round. So if we take a look at the bottom piece of steel, we can see that we've actually got a flat bottom cut out of our hole, and it's not like the one at the top. And we can see that our cap screw head will fit nice and securely there against that. And of course, in the real world, we would have our slightly smaller clearance hole drilled there for the whole of the cap screw to go through, just like so. And it would be slightly smaller, so the cap screw head would still rest nice and snugly. What our drill having a flat bottom will essentially do is cut out the material here either side and clear that out from our original cut, what most drills leave, and essentially leave us with what we can see on the bottom job or the bottom drawing, a nice flat cut out. So it just removes that material there, just down at the bottom. You could call it. You could on here. It's on this drawing. It's like the two corner pieces, but obviously in reality, a hole is round and it goes through the piece cylindrically. So you have to keep that in mind. Also, you will need an original drill in the same size diameter. So if you have broke one and you've sharpened it up like we're getting to here, you will still need to go out and buy a brand new one, because you will need to drill that pilot hole first before you can send the flat bottom down to create that flat bottom. And also, I will state that all drills will follow, even the flat bottom, will follow a predetermined, the predetermined destination of a drill that's already of a hole basically that's already been drilled. So if you've got a hole that's already been drilled like we have here, the flat bottom will follow it straight down of its path. You can try to get it as centered as you can. In a pedestal drill, there are center guides to help you find the center, and you can take those out and put a drill in. It's a little bit like a center punch, really, with like a cone on the end of it, and it'll just sit in the hole, and you'll get that centered, and then you can take that out and put a drill in. But obviously, if you're using a hand drill and things like that, you have to keep in mind that you need to get it as centered as you can. But as long as the hole's been pilot drilled first, all drills will, as long as you get it as centered as you can and not too far over, they will follow that hole straight away. They'll be guided by that pre-cut hole or pilot hole. They will flex a little and travel straight down the hole, but obviously if you bend the drill too much you will break it again, so that's why you need to be as centered as you possibly can get it. It is also possible that I wouldn't recommend it. I'd stick to using the same diameter drill to that you bore the hole and the same flat bottom afterwards. But it is possible. You can imagine a scenario where you need to drill a 6mm hole, and you've just broke your 6mm hole, so you've flat bottomed it on the grinder, and you've probably, if you've got an offset drill, if you're an engineer or a machinist, you likely have lots of different types of drills like that with offsets. Something like a 5.8 or a 5.9, and you could probably drill through to the depth that you were going, and then use that only that you've just broke, the 6mm that you flat bottomed, and that slight material either side, it'll follow the hole and the track of the hole that's already been cut, and it may take that material out all the way down or all the way through the piece, and you might get away with that, but I wouldn't particularly do that. Obviously we're talking about stopping part way through the piece and creating a flat bottom. That's just a little bit extra. Yeah, that's just basically it. You go down first with your the same size diameter, your regular drill the hole, swap the drills, put your flat bottom drill in, and then go back down to that depth and remove the. Okay, so going about creating our flat bottom drill, we can see here we've got a number 6, I think it is. We've got our broken drill. You can see the head there, it's sheared off, and I kept that lying around in front of the grinder actually for a little while, knowing that I can make a flat bottom out of it when I get around to actually doing it. Now we're using a mini home bench grinder, and these safety little fold down safety window things, I know are never much good on them. They always tend to break from the vibrations and God knows what, so they've got to be epoxied back on. But always make sure you've got your safety glasses. You should always wear your safety glasses anyway, regardless of those little silly windows, so I'll just flick them out of the way. Now on most grinders you'll have a coarse wheel and a fine wheel that we've got here on the left. Some though will have one particular wheel, one or the other, and might have a linisher, which is like a belt sander for metal, on the other side. If that's the case, you'll have to make do with whatever wheel you've got. Although it's possible you could polish up the end with the linishing belt as well. You could flat bottom the drill with a linishing belt. So I move the flammable items out of the way, which is the 2 aerosol cans of oil and lithium grease. Clear anything else out the way, any obstacles or anything around by it that might get up and jammed in the wheel. Now with these bench grinders, the wheels on them are very, very thin. They're very big in an engineering room on a pedestal grinder, but like I say, they're really very, very thin here, about the size of that I was, the impression I'm making with my fingers there. And we're taught health and safety reasons when it comes to hand grinding or bench grinding that we're not supposed to load the wheels from the side because they could explode or break. But in obviously with a big bench grinder in an engineering workshop, like I say, they are really thick wheels, so you know that kind of helps when you're trying to get things flat. Don't forget it is a curved wheel, so you've got to be careful as well that you're not going to put a curve on the top. We want that to be flat. So unfortunately, with a home grinder here, we're going to have to go against the grain with the finishing cut and load it from the side where it's flat. That's the only way we're going to be able to get a decent cut, a decent flat cut with this grinder. Is to actually load the side a little. So we've got no choice about that, I'm afraid. But always make sure you got your safety glasses on because of that. So I know health and safety people out there and other engineers, especially the young kids just training, will say you're not supposed to do that. But we've got no choice in this matter. Now, usually in an engineering workshop you'll have a little bit of coolant, a little bit of suds or something in a jar or a little tub. To hand, I've got a little squirty tube of some oil, and I'll just put a blob on the on this lid, and I'll cool the tip of the drill down and just dip it in that oil to stop it from overheating as we grind the tip. Something like a little tub of oil or something like that should do you fine. I know most people haven't got proper suds. Suds, as we call it, it's like a gloopy, soapy substance that keeps the materials cool when we're machining and grinding. Usually when you're grinding you'll have a little tub there to dip your piece in, so but I'm just going to use a little bit of oil just to cool the tip down. It's only a small little tip of a drill. So actually I'm going to use the coarse, I'll use the coarse wheel first to, if you've got one, to grind the majority of that one side that's still sticking up where it can snap. So we'll go back and forth on the front of the drill like we're supposed to, just to coarse it out and rough that out. Yeah, make sure you've got your safety glasses on because those sparks, these small fragments of steel coming off the drill bit, and that can lodge in your eye and you can go blind if you're not too careful. So we pull the tip down, give it another bit, inspect the give it another go, inspect the tip, see if it's getting there and thereabouts, pull it down again. So at this point in time I feel that the drill has been roughed out and it's time to put a much finer final cut. And like I say, we are going to have to use the side of this wheel. I don't particularly like to do that, but we need to get it as flat as possible on this particular small grinder. That is the actual best way that we can do it, even though it's not, or that it's frowned upon anyway. But it's you know, it's the best way that we're going to be able to do it here. So again, take another little look at it. All you want to do is get it flat as you can, straight across the top. Check that yourself. I personally think that's fine now. I'll turn the grinder off. Save me. Always best to turn it off if you're not using it. You might turn around and catch yourself, forget that you've left it on. Again, if you can take a look there, you can see the kind of thing what I'm talking about. Just straight flat across the top, as level as you can get it by eye. So we just show a comparison with a drill that's exactly the same size, but that's obviously still intact, or a regular drill, the tip on the regular drill compared to the flat bottom. And I think I also, there we go, I also have a smaller, I think it's a 4, so a 4 on there, yeah, and you can show, pick up 2 4s there, and obviously one of them is fine and the other one is broke, so I can flat bottom that as well. So I'll just quickly do exactly the same thing with a smaller drill this time. Obviously a smaller drill is a lot harder to do than a bigger drill, because it can move in your hands, and it's obviously more fiddly to hold, and you have to use your eyes on it a lot more. So we're just roughing it out again on the coarse wheel, and because we've got a fine wheel, we're going to do the finishing cut on the fine wheel. I just reposition the camera there, just took a knock, and recall it down a bit, and put a finishing cut on that. And we'll take a look now, just a little nick, recall it down, just a bit of habit. It probably didn't need cooling down, then it wasn't on for very long, but remember, you still have to hold the pieces that you're grinding. If they get too hot, what tends to happen is tends to burn your fingers when they heat up. So that's something else that you need to watch out for when grinding. Again, inspect the tip, this time on the 4mm, and hold it against the regular drill tip, just so you can see the difference. So if you don't get it by now, that is. That should be able to cut out your flat bottom. Remember, it depends where you break your drill. As long as you've still got some twist on there, you should be fine. But obviously, it'll be a shorter drill if you have snapped it pretty much most of the way down. This is my little box of weird and wonderful drill bits, or my HSS drill bits and sensor drills and things like that.